Hi, I'm Mr. Huber, and in this video we're going to talk about problem 2G. Well, look, this is different because it's the first one that has a number in front of the x squared other than 1. So it's the first one that has undergone a vertical stretch or shrink, in this case a stretch. The first 6 all start with x squared or 1x squared. So the first 6 parabolas are all original parabolas, 1 to the right, 1 up, 2 to the right, 4 up, 3 to the right, 9 up, all original parabolas, only that they have been translated to the right or to the left, up and down. But well, here it's the first one that has undergone a vertical stretch, and that makes things a bit harder. You should have tried to do this by now, and maybe you noticed that it's not that easy. So let's start and talk about it. F of x is 3x squared plus 6x plus 7. There are essentially 2 methods to solve this, and I'm going to propose this one. Okay, I'm going to suggest that we're going to factor out the 3 of the first 2 terms like this. You could factor out the 3 from the first 3. That would look like this. 3 x squared plus 2x plus 7 thirds. In most cases, it's better to do it like this. In most cases. Not in all cases, but well, in most. Well, look, what are we going to do now? We're going to complete the square within these brackets. Now, x squared plus 2x plus 1 squared minus 1 squared, brackets closed, plus 7. Okay. Look, why is it the 1? Because it's half of 2 and then squared. And this will be your perfect square. Make sure that you differentiate between the red brackets and the pencil brackets. Now, this is a perfect square. So 3 times pencil brackets x plus 1 squared minus 1 squared is just 1 plus 7. Now we have to distribute the 3 like this. So that's 3 times x plus 1 squared minus 3 plus 7, which is 3x plus 1 squared plus 4. You could have done it like this. It would have been possible. Let me show you that version. But well, you'll see it's not necessary. You could have done it like this. F of x is 3x squared plus 2x plus 7 thirds. Now you do more or less the same thing. F of x is 3x squared plus 2x plus 1 minus 1, both squared, although you don't have to write that obviously, 7 thirds. And then f of x is 3 and then x plus 1 squared minus 1 plus 7 thirds. And now either you distribute first and then you add everything up, or you add these things up and then you distribute. So let's do it that way. It's now the red brackets, x plus 1 squared minus 3 plus 7. And, well, we did this times this, times this, and times this. And we're going to get x plus 1 squared plus 4. But here you see you have factored out your you have factored out your 3, and then you distribute it again, which is just doing something and then in a later step undoing the same thing, which is not useful. Okay, well, here here, when you do this, you can avoid that step and everything works well. That's why I suggest you do it like this. It's much better. Now, is this right? Well, this is a self-correcting exercise, in fact, because you can always work out the general form and see whether it's correct or not. So let's do that. Let's check whether this is still this. So f of x is 3 times x squared plus 2x plus 1 plus 4. Now we distribute 3x squared plus 6x plus 3 plus 4. So it's 3x squared plus 6x plus 7. So that's correct. So this is correct. It's a self-correcting exercise. So the one thing you have to make sure is whenever you factor out your 3, you have to hold on for a second and just rethink it. And once you factor out your 3, you just distribute it. You should distribute it mentally and see, well, 3x squared is 3x squared. 3 times 2x is 6x. Okay, so it is correct. This is a dangerous step. I see very many mistakes here. Okay, now we have this, and we know the vertex is at -1, 4 now, that's clear. The y-intercept is at 0, 7. Now, this could be drawn like this. We could say it's -1, then 1, 2, 3, 4. This is your vertex, and then 1, 2, 3, 7. This is 4. So this would be your graph. Okay. Well, this is still a qualitative sketch, but it's good enough. But you could, in this case, do a better sketch and say, well, the vertex is at -1, 4, and then 1 to the right, 3 up, 1 to the left, 3 up. The next one would be 2 to the right and 4 up, but in this case, because it's times 3, it's 12 up. So it would be here. Let's get rid of these points here, I'm sorry. And then 2 to the left and 12 up there. And this would be your graph. This would be more like a drawing because we have taken care of the vertical stretch, okay? This is not a point. Make sure that's not there. So it's a smooth and rounded shape. It's a vertical stretch. Now we have taken that into account and it's in our drawing. Here it's clearly not perfect, but well, it's more than good enough. This is just a qualitative sketch. This is more like something like a drawing. It's not perfect, but good enough. So I hope it wasn't too difficult. See you on the next one.